G'day and welcome back to my channel. In this video I'll be showing you how to calibrate the LED robotic hand so that you can utilize the Arduino code that I have prepared for this project. The code is available with the rest of the package. For those of you who have printed the hand, I congratulate you. You have successfully programmed the 10 servos and made this device come to life. It is a great achievement to build something from scratches, and you've done it. Good on you. And I hope you keep learning from this wonderful device. For those of you who are just starting with robotics or are still getting familiarized with the Arduino boards and the language that is required to program these controllers, I have written a code that allows you to execute a set of hand movements by introducing a number through the serial monitor window of your Arduino program. For instance, if you type a 2 on the serial monitor window, that will produce flexion of all fingers, while typing a 1 will extend all fingers at once. Typing a 5 will cause the thumb to oppose to each individual finger. Or if you wish, you can create your own moves easily by using the function actuate quick and indicating the amount of flexion and abduction of a particular finger. Instead of using the serial monitor window to type in a value and execute a routine, you can choose to have a more powerful controller to communicate the signal to your Arduino board through serial communication, making sure to connect the RX with the TX and the TX with the RX of both of your boards. But before you can use the code successfully, you need to follow a set of steps which I'm about to show you in this video in order to calibrate the hand, that is, finding the maximum and the minimum limits of each servo motor to operate each finger within its allowable physical range. Operating the hand outside these limits will most likely damage the servo motors. So it's very important to follow these steps not only for this project but for any robotics build you are involved with to determine the limits in which your actuators can operate safely. And we're gonna start with the flexion servos. These are the servos that control the flexion and extension of the fingers. You'll need to upload the code get data from screen on your Arduino board. You'll have to change the value of channel servo to the channel number where your servo being tested is connected to. In this case, it'll be channel 6 to test the servo that controls flexion of the little finger. And I'm gonna start by typing 800 microseconds. This value produces complete extension of this finger. I will then continue to increase this value slowly and carefully till I get to the state where the finger is in full flexion. You need to do this in small increments of 100 microseconds to avoid damaging the servo motor. In here I had finally reached the limit of this servo motor at 1/600 microseconds. Once you know the upper and lower values of this servo, open the Arduino code that controls the hand and change the values of extension and flexion with the values that you just measured. We'll continue running the code get data from screen, and this time we'll change the channel of the servo to 5 to test finger number 4. And we'll follow the same procedure as before by increasing the number carefully and evaluating the outcomes till the finger is in full flexion. Once you know the upper and lower limits of this servo, open your Arduino code for controlling the hand and update the extension and flexion values with the ones you just measured. We'll continue running the code get data from screen, but this time with channel 4 as an input to determine the limits of finger number 3. Update the upper and lower values of this servo on the hand control Arduino code. Continue with the same process, but this time with channel 3 for finger 2. And update the values accordingly. In order to determine the upper and lower limits of the servo that controls flexion of the thumb, remember to adjust the trim pot gear of that finger as described in section 5, step 7 of the assembly instructions to achieve the full range of movement of this finger. As a reference, when the thumb is at full extension and full abduction, the distance between these 2 points should measure around 127 millimeters. Adjust your trim pots so that this is accomplished. We continue running the code get data from screen, but this time with channel 2 as an input to determine the upper and lower limits of the servo that controls the flexion of finger number 1. And update the values on the Arduino code for controlling the hand on the extension and flexion of F1. We now continue with the abduction servo's calibration. With channel 7 as an input, we'll continue the same procedure to determine the lower and upper values of the servo that controls the abduction and adduction of finger 1. You'll have to update the values of adduction and abduction on the Arduino code, bearing in mind that the adduction value is the one that brings the thumb closer to the palm of the hand, and the abduction value is the one that brings the thumb away from the palm of the hand. We are going to continue with the abduction of fingers 2 to 5, and for that purpose I'm going to use a servo tester. I'm gonna set my servo tester to 1500 microseconds, which is the angle that was utilized when installing all of these servos. And gently I'm going to increase or reduce this value till I find the position of full abduction of finger 5. In this case, this value is 1400 microseconds. I will continue with finger 4 to find the position of full abduction. In this case is 1474 microseconds. For finger 3, I'll be finding the value that gives a position of full adduction, that is the closest to the center of the hand. In this case, this value is 1290 microseconds. I will repeat the same procedure for finger number 2 to find the value of full adduction, the closest it can get to the center of the hand, and this value is 1361 microseconds. I will then reverse the direction of that motor to find the position of full abduction away from the center of the hand. In this case was 1812 microseconds. Then moving finger number 3 to find the full abduction position shows a value of 1840. Now I'm looking for the adduction position of F4, the closest it can get to the middle of the hand at 1939 microseconds. And finally, the adduction value of finger 5 turns out to be 1817 microseconds. This is the closest it can be to the center of the hand. Once you have updated all the values of flexion, extension, abduction and adduction on the code that controls the LAD robo hand, you should be able to execute the set of movements that I have pre-established, or you can create your own. For further information, refer to the instructions manual of the LAD robo hand Arduino control. I hope you enjoy this creation and that your knowledge in the robotics field continues to expand. Take good care of yourselves and goodbye for now.